Okay, in this video, I'll show you guys how to use the Simpson's rule with n is equal to 4 to approximate this integral. And remember, when you use the Simpson's rule, the n value has to be an even number. So let's get started. And I'm not going to show you guys how to prove the formula. I will just show you guys how to use the formula in this case. So here is the integral. And perhaps if you would like, you want to have a picture right here, I will give you guys the picture for ln x. So here is ln x. And we are talking about from 2 to 6. So let me mark it right here as 2, because right here, we know ln1 is 0, so this should be 1. So let me just say this is 2. And let's say the 6 is right here. And we are going to cut this into 4 pieces, because n is equal to 4. So I can just cut this right in the middle, and that will be 4 right here, because that's the middle of 2 and 6. And then I will just cut again. So of course, this will be 3, and this will be 5. And as you can see, each of this right here is precisely the delta x. And if you would like, delta x, you can use the formula b minus a, so that's 6 minus 2, divided by n, which is 4. And of course, that's 4 over 4, and that's 1. The picture helps better, in my opinion. And I'm just going to show you guys how to use the formula right here and there. So I will write down S4 for the Simpson's rule. This right here is going to be delta x, which is 1 right here. Okay, it's delta x, which is 1 right here. And for the Simpson's rule, you have to divide it by 3. And the reason is because you're technically using a parabola to estimate the integral. And when you integrate like something to the second power x to a second power, you get something over 3, right? That's why you have the 3 right here in the denominator. But as I said, proof maybe it's for another day. Anyway, here is the inside. We are going to write this down now. You are going to plug in the first x value into the function, and that's just going to be ln2. And you have to remember, the first coefficient starts at 1. And then the next coefficient is 4. And then 2, and then 4, and then so on. You have to really remember that the first coefficient and the last coefficient, they are ones, and the rest will be starting from 4, 2, 4, 2, and so on. They alternate. So the first is ln2. Next, we add it with 4 ln, and you plug in the next x value into the function, which is just 3 right here instead of the ln. And then we just pretty much do the rest. Plus 2 ln 4. And then we add here with 4 ln 5. And as you can see, we have the 4, 2, 4, 2, so on, so on, so on, right? But the next x value is actually our last x value. So I'm not going to put down 2 anymore. It's just 1. So that's just ln of 6, like that. So that's pretty much it. And of course, once you have this right here, you can just enter this on your calculator. This is approximately 5.36 and 32 after that, like this. So this right here is it if you use the Simpson's rule to do the approximation for that integral. And I just want to make a note right here. If you use like a TI-84 or you use any kind of computer software, perhaps you will get the value for the integral from 2 to 6 natural log of x dx. This right here, you get approximately 5.36 and with 4.3 after that. And as you can see, this right here, it's pretty close to this right here. And the beauty is that we only use n is equal to 4 in this case. Imagine if you use n is equal to 10, this approximation would be so much better. But at the moment, this is it.